Hi everyone, and welcome to your next video. Sorry if I sound a little bit nasally today. I think I'm coming down a bit of a cold, but it's another fixing day today. Okay, and what we're going to be doing, one of these things. Okay, yep, it's another screen. Okay, except for this one. Okay, it has a dodgy power supply on it. Okay, got dumped on my desk yesterday to be looked at, and when it works, it tends to switch off itself, and when you do manage to get it to, well, it either switches on or it doesn't switch on, and then when it does switch on, it switches itself off. There we go. Okay, so let's get to it, and I think it's going to be our old electrolytic capacitors in the supply, which are probably knackered. Okay, as we all know, they're not the best component in the world. For those of you who don't know much about electrolytics, and while they're crap capacitors, but necessary evil, I'll tell you a little bit about them, the cons as it were, towards the end. So, first things first, let's pull this apart. Right then, so as usual, we've got clips down the side, and in this case, it's a big beefy screen, so we've got screws at the rear. Now you don't have to undo every single screw imaginable on these screens, okay, on the LCD screens. All that you need to do is to get off the screws which attach the rear to the front. So any of the Visa mount screws, these ones, and some, usually the ones around where the bottom rest attaches, these will be attached to a bracket on the actual rear of the screen a lot of the time, unless it's on the larger screens like the 22 inches and above. Screws won't actually be attached to the front panel, so let's skip over those. So we can start unscrewing. Crosshead, okay, just a medium size crosshead. What's this? This is a Phillips size 1. And slowly unscrew everything. If you're not too sure about what screws to unscrew, then unscrew absolutely all the screws. Okay, there's no harm in doing that. Just to keep this slow, I've actually took apart one of these before in the past, so I know that it's just the 4 screws that actually hold this back panel on. Okay, and stand it up, and we can just unpop the tags. So that's one up, 2 out, 3. We have another one down around here. Unreleased. That one's released. That one's released. Okay, and as you can see there, it's all opening up down the side. Okay. Come on, thank you. That's that one gone. And slowly go around all the bezel. As you can see, it's starting to pop out on the other side as well now. So where's the next one down? There it is. That one can come out there. That one can come out there. On the bottom. There we have it. Okay. Okay. VJ cable at the rear down here. This is actually attached internally. So has to be go through the rear like so. Okay, and here we have it on the screen. Okay, as I said before, it's only the 4 screws. Okay, holding this back on. So what have we got? We've got a big chunk of metal. So This is where our circuitry is. Power supplies generally go over on this side. VJ in, audio in. Got a cable down here. This one goes off from the main board down to our little display board down here for all our controls. Speaker cables, and back here we've got our cable for our actual screen, all our screen connections. Okay, back to the LCD panel. So over here we've got our earth bond clip. Everything is all shielded properly, so let's take the shield off, get down to the actual circuit board. Just the 4 screws, a couple of clips on the side. Come on, you're coming out. You don't want to come out, right? Let's just put a screwdriver underneath there just to get it in the clip here. There we go. Okay, it's well shielded, so don't have to worry about EMI, all that crap. Those particular panels, these old ones are really built. Come off of there. It doesn't want to release off this one. Very. At last, one full screen off, and what are we left with? Well, turn around this way so we can actually see what we got. Okay, so we've got our main processing board and we've got a power supply board. That's all that there is to it. It's just this main board. Power supply comes in on a edge connector. Looks like you've got 2. One's probably for monitoring. Maybe one looks like it's for the power levels. VJ's plugged straight in. You've got a VJ. Actually, we've got some cables here going back to a VGA socket here on this connector. If you wanted to do a hack and there was something wrong with this cable, okay, what you could actually do is right angled 15-way high density, solder it straight in, and then you could chop out a hole. You can put in a mount, mount 15-way high density, just plug it straight in. Okay, so if there was anything wrong with this, you could plug it straight in. Not a problem. It looks like that has been left out. Supply it with a cable, one less connector to worry about, make it cheaper. Whatever. Anyways, what's wrong with it? Nothing really wrong with this board. I can't see any scorching or anything on the chips. There's no actual obvious thermal damage. Caps all look fine. Over on the power supply side, everything looks okay. No resistors particularly burned or show signs of heat damage, but take a look up here. Straight away we can see these 1, 2, 3, 4, 5, 6 caps here are in actual fact knackered. Is that one gone? No, that one looks okay. That one looks fine. Fine. That one, yeah, fine. Okay, all these ones look okay. But around this side here, probably decoupling caps. It looks like they're in pairs, so it's probably positive and negative power rails. They look like the culprits, and I can tell they're the culprits because one, these larger ones are showing signs of venting. You can actually see the electrolyte creeping through the top vent. These two, and also they're quite bulbous. So I'll try and get a better view of this. Alright, let's have a close-up look. Okay, so like I said here, this is our main processing board. Over here, this is the power supply, this is the culprit, and these are the culprit components. So I don't know if you can actually see that from that angle. Okay, but you can actually see the top of these are actually bulging. Okay, if you compare those couple there with say that cap down here, you can tell it's a nice flat top, no sign of any venting or anything like that. Likewise with that one sitting down there, it's larger one here for smoothing one on the actual power supply side, on the main supply. This one here, after it's all been regulated down, so it looks like it's regulated down and goes off to this edge connector. These are all quite knackered, as I said. You can actually see on these large ones, you can actually see this on the centre. I wiped it off on this one, unfortunately, where I was showing you, but you can just about see the little brown blob creeping through. That's the electrolyte and the actual cap slowly venting out. These ones all go the same way because they're bulging, and yeah, they're the ones, they're the culprits, so we'll swap those out and hopefully we'll get a working screen. Off we go, back with a screwdriver, get this board out. So first things first, we disconnect all the cabling. So earth clip, we'll leave that last, because it's an easy one to get out. These are all just pushing ones, so we go, come out of there. That's this one out, that one comes out. This is actually power for the, where's that one going to? This one is actually, it's going to a speaker. It's interesting. Why have we got a speaker coming from here? Anyway, we've got two over here. They're the backlights. Okay, top backlight, bottom backlight. Earth clip going straight back to our earth point. Yeah. Okay, so we will pull those out. Pull those ones out down here. Yeah, and I'll move it. There you go. So these ones come out. I was talking about backlight. Power's out. This speaker connection comes out. Don't know why they'd feed it through there. Peculiar. Same with this one as well. Have a speaker wire from here. Also goes to this power board. Left and right. It's very odd. It actually looks like this cable here is actually audio left and right. Feeds into the main from the main board from this stereo jack. Goes off down to our power supply board, and I've actually mounted the an audio amplifier onto the power board itself rather than on the main processing board. Why? I don't know. And then it's fed off to left and right with a coupling cap. Probably over here, that might actually be the supply for, or it might be the supply from around, who knows. Can't tell from this side. Anyway, everything's unplugged. And the board, let's unscrew our ground clip. Okay, and we can slowly take our board out now. Let's unscrew the board. Four screws. Normally, there's the fourth one. Over here on that bit of shielding over here. And this board should come out. I don't think there's any other screws holding this down. There we go. And we're out. Okay. Yep. So, what have we got here? We got audio in, audio out, got a bit of support circuitry. Power comes in actually from up here. There's a little power supply for it up here. Okay. Very peculiar. I don't know. Must have run out of board on that one. And I thought, well, we've got a bit of space left over on this board, we might as well whack it on there, save expand on that one, save that one, and hell, save ourselves a bit more money. Okay, we spread it across. And if we actually do that, this is where the trouble spot was. There's no actual thermal damage around that area. They are in actual fact decoupling caps. Okay, they go between the actual 0 volts side to positive supplies. They come in from this transformer. Yeah, actually, some across the transformer, some across these components here. Looks like it's a bridge. Yeah. Yeah, so we've got a transformer going to a bridge. It's heading off to these caps here, just for suppression. So it looks like this is just dropping the voltages, smoothing them off to whatever. So yeah, looks like that is a supply problem going off to the main board. If this isn't supplying enough, if these caps are gone, the ESRs are probably completely shot. The values are dropped. Working voltages have all changed. So yeah, that'll have a dramatic effect on the quality of the DC output supplying our board, which would cause it to not power up properly or shut down or be very intermittent. Okay. So what we'll do is swap out those caps and we'll take it from there. Actually, before we go into the lab, I've forgotten to do something. I haven't looked at what values that I actually want to look for. So, what do we need? Where's a bit of... do I need a bit of paper? There's only 4 capacitors, ain't it? No, it's 6 capacitors. Alright, what values do we have? Take a look on the side of the can. It's not particularly visible on these ones. Okay, it's a dark can with dark writing, pain in the arse. These are actually branded Philips. So there we go. We've got Philips ones. Good brand, good maker cap. I think they're actually coming out of the passives market, the component market. Actually, Philips is really shortening down what they do. Anyways, what values have we got? Reading off the side. Luckily for electrolytics, they do print them on the side. There we go. That is a... come on, what value is that? Alright, pain in the arse trying to find a value on this one. These ones aren't Philips ones though. These are Asicon, so that right over. Okay, so we've got 470 micros. That's on these big ones. You can see that one okay. At 470. Yep. What am I doing pointing to these? It's down here. That's what I'm looking at. Yep, 470 at 16 volts. Down the side. Working voltage is 16 volts, is 470 microfarad cap. These ones are down the edge. 1000 micro 10 volt and a 1000 micro 16 volts. Well, I know for a fact that I've got 1016s. So I can replace all these. I can replace the 1010 volt ones with 1016. That's not really going to matter too much. If anything, the ESR will be a lot lower, so they'll operate a little bit better, being a higher working voltage. I can do a direct replacement on those. I've got some 470s. I think I've got some 470 16 volt ones knocking about. May have some 10 volt ones. But I've got the 16 volt ones. It may be a little bit more tricky getting those in because the 16 volt ones might be slightly wider. Okay, I'll have to see if those actually fit. Anyways, let's go find what I can find and we'll desolder and solder in some new ones. Right. here I am in the little dirty area for soldering. Got my caps down here. Okay, replacement electrolytics. I've got some 1000 micro 16 volters, some 470s there, 16 volt ones as well. 470 16 volt ones are actually smaller than the original ones that are in this board. Okay, so we're going to replace it with that one. As you can see, it's a lot smaller nowadays, and same width, so okay. They are 16 volt, they are 16 volt, and so are they. Yep. 1016 volt, so they're exactly the same size as these two back here, a little bit bigger than these because these are the 10 volt versions, but same widths, same height profiles of these, so they're not going to hit the shielding or anything like that, and 16 volts, so they'll be less likely to go compared to the original ones. So let's start desoldering these caps. So it's ones around this area here. That one, that one, that one, and that one, and that one, and that one. Let's get with it. Just using a normal hand solder sucker, iron. You might want to whack up the heat on your iron to a little bit higher than normal, because these caps are actually connected on to the huge ground side of this board. Okay, it's actually connected to the earth shield, so yeah, they are decoupling ones. And you want to whack up the temperature on your iron simply because it's a large surface area of copper that you're trying to heat up. So we'll whack out these caps. Iron on. And they're coming off nice and easily. You can tell it's a plus and minus supply as well, since that these electrolytics are polarised and they are actually reversed. So you've got a 470, two 470s, and they're reversed on the rounds. One for positive, one's for negative. Same with the two, with the four 1000s. If they have gone, yeah, well, you're gonna definitely have a problem on your supply rounds. Last two caps, it's that one and that one. Beauty thing about this board is that they've actually done marking on the underside as well as the top side, so you know exactly what component you're desoldering. So they really have designed and labelled up this board pretty well as well. It's even got the plus and the plus signs, so you know exactly which way around the electrolytics have to go, since that they are polarised. Everything's all desoldered on that side. Flip it over. We can just pull out the caps. So these ones are the 470s. They can come out. These ones can go in. Okay, top side is actually marked. Bottom side is marked with a plus, and the top side with the black mark, so we know exactly which side is our negative side. So in this case it will be positive on this side, which will be the black side. In the case of the top, it's actually the black side is the negative. So it goes through that way, and it does correspond. So they can go in around that way. Black is negative. Positive. bend the wires out so they don't go anywhere. 2 large caps can come out. Exactly the... oh dear, this one coming out. I don't think yeah, I haven't desoldered this one particularly well. So let's just put the iron back on this on just here. I'll whack out that a little bit more. Okay, I'll pull those ones out. These are all the same value ones, so we might as well take out all these all at once. And we can whack them all in. Okay, so like I said, they are coded on top, black and white. The black side being the negative side. And we'll go. Yeah, they're all in. Hold them in place, flip it upside down, bend the legs out. And we're done. And these are actually 2 1000s in parallel. You parallel them up, you reduce your ESR, and again you increase your capacitance. So your capacitance goes up, your equivalent resistance goes down. Good tip. Okay, so if you've got high values, you can parallel up, and it does improve rather than sometimes if you've got a space constraint. If this was actually, what's this, 2, that'll be, what, you're doubling it up, that'll be 20 2000s. You'll probably find that this, a 2000 won't actually fit onto this board. Okay, it'll be too high, and yeah, problems all over. Nothing will fit, which is why they've gone for the 2 in parallel. Save space. Again, right then, so let's start soldering up these. Iron on. And we go. So it shows you in the soldering video. Iron on one side, flow the soldering from the opposite side. And one other problem. Electrolytics don't particularly like heat, so don't keep your iron on for as little too long. You only need it for a few seconds on each cap. As soon as you've got enough solder on there, take it off. There we go. Run out of that. Got a bit more solder here. Okay. Always use a fairly lengthy bit of solder. Okay. You don't want to burn your fingers. And there we go, everything's all soldered in. Just trim them back and we can slap it all back together. Trusty side cutters, okay, the angled bottom. You can get in close and you can snip your wires. These ones are quite old and worn, so they're not cutting as well, but yeah, it's good enough. Doing the job. We have it. Everything's soldered in. New caps are on. Lovely. All that we need to do is to reattach it, plug everything in and switch it on. we're back, and let's sit this board in. So make sure all of your wires are out of the way, they're not going to get trapped. Slap the board in, push it down, there we go, done. What I'll do first is just maybe screw in 1 or 2 screws just to make sure that the board's in place. We can switch it on with the cables plugged in and see if we get any life out of this. Okay, that way we don't have to you know, unscrew absolutely everything. So, cables back in. If you've got a hell of a lot of cables, it's always good to do a video or take a few pictures, as I said before. It does help. In this case, sockets are more or less where they should be, cable lengths are as they should be, so you can't really go wrong plugging things in the wrong place. What did I do then? Oh, I thought I bloody well sparked something then from the supply, but it wasn't. There's a screw dropped. Right. Always chumpy when I'm working around power supplies. Ever since I got myself electrocuted as a young engineer, not paying attention to what I was doing. I left the actual TV on when I was servicing it. So I was using a multimeter, going around checking voltage levels. Forgot to switch it off, and I started bloody well poking about with my fingers, and I got a bloody right nasty shock off the mains. So yeah. Right, so cable in, cable in, cable in, cable in, cable in, backlights are all in. So let's see what happens when we start plugging things in. Okay, so that's all plugged in, that's all plugged in. Turn it up, turn it around, and let's see what happens when we switch this puppy on. Okay, so you've got our power button down the bottom here. Got a green LED when it's on, orange one when it's in power save. So hopefully when we switch it on, there we go, green light, lovely. Nothing on the screen. There we go. No VGA detected. We have a screen. Switches off. On. What do we get? Anything in particular? Yeah, back to that. Yeah, we've got a menu down the bottom. Audio and what have you. Contrast. Hey, lovely. Right then. So, let's switch this off. Screw the back on. And off we go. Typical. I did get a phone call when I'm doing a video. No, couldn't have been important, they buggered off. Alright then. Let's screw everything back to where it should be. So I'll plonk in the other screws on this. I had 5 screws, 3 of them have already gone in. That one goes into there. This one go down here. Make sure that you do get the right screws in sockets, unlike then. That's my shield screws. This is one of the ones for the actual board. You can tell by the thread and the shape of the screw. Alright, that's all in. Shield, if you've had to bend back the shield at all, bend it all into place. Back in. And whack it on. And so that goes, that cutout follows this. Mains connector down here. Okay, and pull it all back on. That goes onto there. Make sure that it all stretches over, nothing gets caught. There we go, not trapping any cables or anything. Make sure click into position like that. Lovely. All the holes line up, we can screw the shield in. Done. Okay, one thing left to do. Place it back into the case. Okay, so pull the wire through as it goes in. Make sure nothing's caught. Sit the bottom in first. Like that. All the clips will clip back in. Lovely. Turn it back over. 4 screws remaining to go into the back. And we have our working screen. Cost of components, couple of electrolytics, what? £2. Left absolutely nothing for me because I already had them in stock from a previous repair. So, didn't actually cost me anything. Okay. Yes. One screen, back up and running. And there we have it. Okay. Sorted. Alright, electrolytics. They are, unfortunately, a necessary evil in electronic engineering. Okay, but why do we have them? Why are they a necessary evil? One, if you want a very high value of capacitor, you know, hundreds of micros, thousands of micros, yes, it's going to be electrolytic. There's no way back. Okay, and basically electrolytic is a 2 plates of your capacitor sandwiched together with a dielectric, just like a normal one, except they've got an electrolytic in there. Normally it's a paste or a liquid or something. That stuff generally dries out, okay, over time, so they do have a short lifespan. That's one thing. Because there's a liquid in there, or paste or something, hence they don't like heat. As you heat it up, okay, it turns gaseous, slightly gaseous, and it causes the case to swell up. As it turns into a gas, it dries out, okay, you get left with less stuff. All your values start to go doolally. Another problem, they are polarised. Okay, one side's positive, one side's negative. Put them around the wrong way, bang. Okay, they've got also a working voltage. Okay, working voltages for electrolytics can be quite low, they can be quite high. Okay, the higher there it is, the larger the capacitor size, lower your ESR, that's your equivalent series resistance. Okay, so a nice high working voltage is nice. Trouble is they get very big, so you like to keep them down low. Lower they go, your ESR goes up, and you can only work from a lower voltage. So again, a pain in the arse. So there's lots of pros and cons to, well, more cons than there are actually pros for electrolytics, but they are a necessity where you need high value capacitances, things like in power supplies, rectification, voltage doubling, pump charges, things like that. You can't really get away from them. Decoupling, coupling, very, very low value field. So on mains and audio level, you can't really shift out of them. The only alternative you got is tantalum, and tantalum doesn't cover the same range that electrolytics do, so you're more or less stuck with them. They are getting better, but yeah, we're stuck with them, and they are a point of failure in a lot of power supplies. So if ever you get a power supply problem, always take a look for the electrolytics and have a look to see if they're venting, they've got any crud coming out the top, or they're bulbous. Either one of those or both, they need replacing. Anyway, see you next time.